Welcome to Balaya Math Lectures. Learn every step. Today we are going to learn normal form of a matrix. Suppose a matrix A have a rank R and is of order m by n. Suppose A is a matrix of order m by n and it is having rank R. Now you can reduce this matrix into identity matrix. If suppose A is a square matrix, then it can be reduced to identity matrix by applying elementary row and column transformations. Your matrix A has rank R and which may have R by R order. That means the matrix directly goes to identity matrix. Now if suppose m greater than n, that means the number of rows are more than the number of columns. I am giving you one example here. Suppose 1, 2, 3, 2, 1, 6, 1, 2, 1, 3, 2, 3. What is the order of this matrix? This is a 4 by 3 matrix. That means the number of rows are 4 and the number of columns are 3. So whenever m greater than n, and suppose this is a matrix of rank 3. Now it can be reduced to I3 0, which means your last row will be 0 and the rest of the matrix will goes to identity matrix of order 3. That means I3 0. If suppose m less than n, that means the number of rows are less than the number of columns. If suppose if you have a matrix 1 2 1 2 1 2 1 2, how many rows are there? 2. How many columns are there? 3. That means this matrix may have a rank less than or equal to 2. If suppose it is a matrix of rank 2, then this will goes to I2 0. That means this will be identity matrix, this column will be 0. That is denoted with I2 0. And if suppose m not equal to n and the rank is less than the number of rows and number of columns, which means suppose if you have a matrix 1 2 1 2 2 1 2 3 minus 1 2 6 3 1 2 1 4. This is the matrix. I am supposing not exactly the rank of 2. This matrix does not have a rank of 2. If suppose the rank of this matrix is 2, then this can be denoted with I2 0 0 0. That means this will be the identity matrix 1 0 0 1 and the rest of the rows will be 0 and the columns are also 0. Rows are also 0, columns are also 0. This is denoted with I2 0 0 0. In any one of the form of this form, then that is called normal form. That is called normal form or canonical form. Now let us reduce the matrix into normal form and find its rank. So here is the matrix 0 1 2 minus 2 4 0 2 6 2 1 3 1. Let A is equal to 0 1 2 minus 2 4 0 2 6 2 1 3 1. The first row, first column, first element of the matrix must be non-zero. But here is the matrix which contains the first element as 0. That's why I am interchanging first column and second column. Then C1 if and only if C2, which means 1 0 1 0 4 2 2 2 3 minus 2 6 1. Here is the procedure that first of all you have to use this element and make these two elements as 0. But fortunately you have 0 here, So it is enough to make this one as 0. And then immediately you can apply elementary column operations, use this element and make these 3 elements as 0. Here it is already 0, so it is enough to make these 2 elements as 0. And then after, use this element and make this element as 0 after applying elementary row and column operations first time. Okay, in the second time you will use this element which may be 0. If it is 0, you will interchange the row. If it is non-zero, then you can use it one and make this element as 0, and use the same element and try to make these 2 elements as 0. Finally, use this element and make this element as 0. The last row may be completely 0 and 2 columns may be 0. If all the 3s are non-zero rows, at least 1 column must be 0. Then you will get the normal form. Now let us start the procedure. Use first element and make this one as 0. How? R3 tends to R3 minus R1. Then no change in first 2 rows because I am not applying any elementary row transformation on first 2 rows. So that 1, 0, 2, minus 2. 0, 4, 2, 6. 1 minus 1, 0. 2 minus 0, 2. 3 minus 2, 1. 1 minus or minus plus 2, 3. Now, use the same element and make these 2 elements as 0 by applying elementary column operations immediately. Don't go for this element and try to make this one as 0. First of all, you need to apply elementary row transformation and make these 2 elements as 0. And then after you have to use elementary column operations and make these 3 elements as 0. This is the procedure. We strictly follow this thing. Okay, right. So let us use elementary column operations and make these 2 elements as 0. That means C2 tends to C2 minus 2C1, C3 tends to C3 plus 2C1. So no change in first 2 columns, those are as it is. That means 1, 0, 0, 0, 4, 2, C2 minus 2C1. That means this is 0. 2 minus 0, 2, 1 minus 0, 1, and minus 2 plus 2, minus 2 plus 2, 0, 6 minus 0, 6, 3 minus 0, 3. Now, use this element and make this one as 0. How? R3 tends to 2R3 minus R2. 2R3 minus R2. Use this element and make this one as 0. How can we do this? Multiply this one with 2 and subtract second row from this row. That means you will have the resultant as 1, 0, 0, 0, 0, 4, 2, 6, 0, 0, 2 minus 2, 0, 6 minus 6, 0. Now use the same element and make these 2 elements as 0. How? C3 tends to 2C3 minus C2 and C4 tends to 4C4 minus 6C2. Then these 2 elements will be 0, which means no change in the first 2 columns. 1, 0, 0, 0, 4, 0, 0, 0, 0, 0, 0, 0. Now simply divide the second row with 4. That means R2 tends to R2 by 4. Then what will happen? 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0. What is this? This is equivalent to I2, 0, 0, 0, which is called normal form. And the rank of the matrix is nothing but the order of the identity matrix. Therefore, rank is equal to 2. This is in normal form, which is in normal form. Normal form. And rank is 2. This is the way how to find the rank of a matrix by reducing it into normal form. Let us see one more problem. Let the given matrix can be taken as A. So, what is the procedure to reduce the given matrix into normal form? Take this element and make these two elements as 0 by applying elementary row operations. And then after, use the same element and make these three elements as 0 by applying elementary column operations only. Here is already 0, so it is enough to make these two elements as 0. That means R2 tends to R2 plus 2R1, R3 tends to R3 minus R1, which means no change in the first row. 1, 2, 1, 0. Minus 2 plus 2, 0. 4 plus 4, 8. 3 plus 2, 5. 0 plus 0, 0. 1 minus 1, 0. 0 minus 2, minus 2. 2 minus 1, 1. Minus 8 minus 0, minus 8. Now, you have to apply elementary column operations immediately and make these two elements as 0. That means C2 tends to C2 minus 2C1, C3 tends to C3 minus C1. So, no change in the first column. That means 1, 0, 0. 2 minus 2, 0. 8 minus 0, 8. Minus 2 minus 0, minus 2. And 1 minus 1, 0. 5 minus 0, 1 minus 0. No change in the last column. Have you noticed one thing? That while I am applying elementary row operations, I am writing rows. While I am applying column operations, I am writing columns. So this is the procedure what you have to understand by observing the procedure. Okay. Now use this element and make this one as 0. How? R3 tends to 4R3 plus R2. Because 4 into minus 2, minus 8 plus 8 becomes, this element will becomes 0. That means no change in first two rows. 1, 0, 0, 0, 0, 8, 5, 0, 0. This is our target which is to be 0. So 4 plus 5, 9. Minus 8 into 4, 8 4 is 32, minus 32. Now, use the same element and make this one as 0. If it is non-zero, you have to make this one also 0. But here is only the element which is non-zero, so you should make it as 0 by applying elementary column operations immediately. So, you need to apply elementary column operations. C3 tends to 8C3 minus 5C2. By applying this operation, what you can see? No change in first two columns. So 1, 0, 0, 0, 8, 0, 0. Our target is 0. 8 9s are 72. No change in the last column. 0, 0, minus 32. Now what you need to do? You have to use this element and make this one as 0. How? Multiply this one with 72 and multiply this one with 32 and add these two. C4 tends to 72 C4 plus 32 C3. Then this becomes no change in first three columns and the last column becomes 0. Now what can you do? R2 tends to R2 by 8 and R3 tends to R3 by 72. R2 tends to R2 by 8 and R3 tends to R3 by 72. What it will be? These two elements will be 1. That means 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0. What is this form? I3, 0. This is in normal form. So, the rank of the matrix is 3, which is the order of the identity matrix here. Therefore, rank is equal to 3. I think you got how to find the rank of a matrix by reducing it to normal form. So you need to solve two problems which will be homework for you. Find the rank of the matrix A is equal to 2 minus 2 0 6 4 2 0 2 1 minus 1 0 3 1 minus 2 1 2 by reducing it into normal form. And the second problem is reduce the matrix capital A is equal to 2 1 3 4 0 3 4 1 2 3 7 5 2 5 11 6 into normal form and hence find its rank. I request you all, please like, share, comment and subscribe my channel Balaya Math Lectures. Learn every step. Thank you.